Hello everyone, this is Dr. Surya. Today we are going to see about hydrostatics and hydrostatic law. So what is this hydrostatics? It is the one which deals with the characteristics of fluids at rest, and mainly it deals with the pressure in a fluid or when it is exerted by the fluid on an immersed body. So generally this principle of hydrostatics will be used in the problems that is related to pressure in deep water. Why it is used in deep water means pressure will be increasing with depth, and in the same way it can also be used in high in the atmosphere because pressure lessens with altitude. So I can tell you what is this hydrostatic pressure actually. So consider a water tower. So this is an water tower. You can see the figure here. So this is a water tower you might have seen, and we call it as water tanks. What happens here in the water tank? So we are keeping this water in a high pressure because of its elevation. So in an elevated level we are keeping a tank, and because of that elevation the water is getting it will be in a high pressure. So what happens when we open this valve or something like that? The pressure will be acting in the water, and automatically the water will flow with due to gravity. Okay, so due to this happens because of the hydrostatic pressure. So this water is forced into the lower lying houses which is nearby in the villages or nearby the area. Without any additional pumps the water can be delivered to the water. So this delivered to the houses. So this is one example of the hydrostatic pressure. And similarly you might have seen some water cans, that is watering the flower pots or watering the flowers. You might have seen that is watering can. So this is also one example for the hydrostatic pressure. That is something like that, the spout and the water level, that is we call pouring pipe as spout. In Tamil they call it as poovali, like that they'll tell. So the same water level will be set in the pouring pipe as in the can itself. So this is also mainly due to the hydrostatic pressure. So now we are going to see about hydrostatic law. The pressure variation at any point in the fluid at rest can be obtained using this hydrostatic law. So what does this hydrostatic law state? It states that the rate of increase in pressure in a vertically downward direction must be equal to specific weight of the fluid. So what is the specific weight? So specific weight W is equal to rho G. So we are going to prove that the rate of increase in pressure in the vertically downward direction is going to be equal to the specific weight. Okay, now let this be the small element. We can say that some small element which is immersed in water. Say let del A be the cross sectional area of element ABCD. Del Z be the height of fluid element, and P be the pressure on face AB. Okay, and Z be the distance of fluid element from free surface. Okay, now what are the forces that will be acting on the fluid element? We have to see to that. So forces acting on the fluid element. Okay, so three forces will be acting upon. So one is the pressure force on AB. In AB there will be one pressure force, and in CD there will be one pressure force. Apart from that you are having the weight of the element also. That element will have some considerable weight. So three forces will be acting upon. So we are going to see to it. So first one is pressure force on AB, on face AB, which is equal to pressure into area. So force is pressure into area. We have seen this in the last video itself, and it will be acting perpendicular to face AB in the downward direction. So in the figure, if you see, this pressure will be acting in the downward direction. So pressure into area. So second one will be pressure force on CD. So if you take here, already this pressure force on side AB is there. Apart from that, this area is also there. This here also, in this area is also there. We have to include that also. So there will be a small increase in pressure will be there for this water, or because of that element. So up to here the pressure is P. So when it is comes to here, there will be a small increase in pressure. So we are taking that small increase in pressure to be dou P by dou Z. So what happens is P plus dou P by dou Z into del Z into del A, and this force is acting in the downward direction, and the second force, that is the force on CD, will be acting in the upward direction. And the third one is weight of fluid element. So the formula for weight is nothing but mass into acceleration due to gravity. So this is a general formula. Okay, and instead of mass I can write in a differently, that is density is equal to mass by volume. So my mass will be equal to volume into density. I can write like this. So weight of fluid element is equal to density into volume into acceleration due to gravity, that is G. So my weight will be equal to density, I can denote it as rho, and gravity G. Volume is area into height, I can put it. So del A into del Z of the element. So I have determined all the forces. Now I have to see to it, that is I have to take care of the equilibrium condition, that is pressure forces on surfaces BC and AD will be equal, and also they will be opposite. So if you take in the figure, so the pressure forces on BC and AD, they will be equal and opposite. So we are going to consider the equilibrium condition. So three forces are there, as we have mentioned earlier. Downward force we are going to denote it as negative sign, and upward force we are going to denote it as positive sign. Okay, so first downward force is pressure due to gravity. So I am taking that into consideration. So which is, it is a downward force. So P into del A. And next is the pressure on face CD, which is an upward force. So which is P into, so I am putting positive sign, dou P by dou Z into del Z into del A. Then next is your weight of fluid element. So weight will be generally it will be acting in the downward direction. So I am putting minus sign here. Rho G into del A into del Z is equal to 0. Now just abbreviate. So P into del A plus P into del A plus dou P by dou Z del Z into del A minus rho G del A del Z is equal to 0. So minus P del A and plus D del A will get cancelled. So dou P by dou Z into del Z del A is equal to rho G del A del Z. So del A, again del A and del Z will get cancelled. So I will be having dou P by dou Z is equal to rho G. Okay, so I can easily integrate this equation, or I can say that specific weight or weight density is equal to rho G. So this states that the rate of increase of pressure in a vertical direction is equal to the weight density of the fluid at that point. So this is called as hydrostatic law. Supposing if I integrate this equation, that is dou P by dou Z is equal to dou G. I am just integrating it. So dou integral of dou P is equal to integral of rho G rho Z, I will be getting P is equal to rho G Z. Okay, where Z will be the pressure head. And also it is the height of the point from free surface, and P is going to be the pressure above the atmospheric pressure, and Z will be equal to P by rho G. We are going to start to solve a problem. So the given problem is a hydraulic press. So what is this hydraulic press? So it is nothing but a small force. It is utilized to lift a large load. So hydraulic press has a ram of 30 centimeter dia. So we have to write a given data. So I am keeping the diameter of ram as capital D, so which is equal to 30 centimeter, which is equal to 0.3 meter. So I am converting it into meter. And a plunger of 4.5 centimeter dia, so which is small d, 4.5 centimeter. When I am converting it to meter, it becomes 0.045 meter. And find the weight lifted by the hydraulic press. So they have asked to determine the weight that has been lifted by the plunger, and we are going to apply a force on the plunger is 500 Newton. So the force on the plunger, so I am keeping it as capital F, which is equal to 500 Newton. So this is what is given in the problem. So you can see the diagram on the right hand side. So something like that, the setup is called as a hydraulic press. When we are applying some force, automatically the weight that is kept on the ram is going to be get lifted by applying some force on the plunger. So what is the weight? Weight lifted by this hydraulic press when we are applying some force. So how much weight does it get lifted? So this is what we are going to determine. So first what I am going to do is I am going to get the area of ram. So I am keeping it as AR. So area of ram is nothing but pi by 4 d squared, which is given in the problem. D is given in the problem. So pi by 4 into 0.3 square, so which is 0.07068 meter square. Then I am going to determine the area of plunger. I am keeping it as AP, pi by 4 into small d square, so which is pi by 4 into 0.045 square, so which is 0.00159 meter square. Now what will be the pressure intensity due to plunger? So I am going to determine that how much pressure intensity is going to be developed because of that plunger. So this we have seen, we know the formula already, which is force by area. Force on plunger, similar to stress, that is called as a pressure intensity. So force by area of plunger. So force is known to us, area is known to us. So which is 500 by 0.00159 Newton per meter square. So this is what it's a pressure intensity. In simple I can say that 314465.4, so which is 3,14,465.4 Newton per meter square. So this is what is the pressure intensity due to plunger. But we have learnt in the past Pascal's law that intensity of the pressure will be equally transmitted in all the direction. So here comes the application of the Pascal law. So by using the Pascal law, we can say that the intensity of pressure will be equally transmitted in all direction, which means pressure intensity at ram and plunger is going to remain the same or same. So this has been achieved due to Pascal's law, as per Pascal's law. Okay. Now, so what will be the pressure intensity at ram? It is also going to be the same one, which is 314465.4 Newton per meter square. And we are going to we have to get what is the weight we are going to determine. So we are going to use this. So pressure intensity at ram is equal to weight by area of ram. So weight will be equal to pressure intensity at ram into area of ram. So pressure intensity at ram is 314465.4 into area of the ram we have determined already, so 0.07068, so which is equal to Newton, which is equal to 22.22 kilonewton. So this will be our answer. This problem is a very easy problem. So calculate the pressure due to a column of 0.3 meter of water, oil and mercury. So three different liquids are given here and we are going to calculate the pressure due to a column of 0.3 meter. So I am just mentioning this as height of liquid column. Height of liquid column, say Z is equal to 0.3 meter, and we know that pressure at any point in a liquid, that is we are going to use our hydrostatic law, something P is equal to rho G Z. We are going to use this formula. So first liquid is going to be water. So for water, P is equal to rho G Z. So we know density of water is 1000, specific gravity, acceleration due to gravity is 9.81 and Z is 0.3. So my pressure due to water will be 2943 Newton per meter square. Second one is due to oil. So they have told that oil is having a specific gravity of 0.8. So generally if specific gravity is given, so we have to determine the density of that particular liquid. So which is specific gravity is equal to density of liquid by density of water. Here the density of liquid is going to be density of oil by density of water. So density of oil is equal to specific gravity into density of water, so which is nothing but 0.8 into 1000. Now I can write the pressure is equal to density of oil, that is rho G Z. So here density of oil, so which is equal to 0.8 into 1000 into 9.81 into 0.3, so which is 2354.4 Newton per meter square. Next I am going to determine for mercury. The same here also, density of mercury is we have to find it out. So density of mercury will be equal to specific gravity into density of water, so which is equal to 13.6 into 1000. So now pressure will be equal to density of mercury into G into Z, so which is 13.6 into 1000 into 9.81 into 0.3, so which is equal to 40025 Newton per meter square. So we have calculated the pressure due to column of 0.3 meter of water, oil and mercury. Okay, the next problem is that an open tank is containing a water up to a depth of 2 meter and above it an oil of specific gravity of 0.9 for a depth of 1 meter is found. Find the pressure intensity at the interface and also at the bottom of the tank. This is what is given to us in the problem. So first one, I am drawing a diagram of an open tank. The tank is open here and bottom 2 meter it is water and above 1 meter it is oil. So I have drawn a diagram. So next I am writing the given data. So which is height of water. So I am taking it as Z1, so which is going to be 2 meter. Then height of oil, so which is my Z2, that is 1 meter. And apart from that I have given a specific gravity of 0.9. Okay, so if specific gravity is given, we have to get the density of that particular liquid. So specific gravity is equal to here density of oil by density of water. So density of oil will be 0.9 into 1000, so which is 900 kg per meter cube. Now what is asked in the problem? So the first one is at the interface what will be the pressure intensity, that is at phase AB. So pressure intensity, if you take in the problem, what will be the pressure acting on the phase AB will be only due to the pressure of oil it will act. So I will be considering only the pressure due to oil, that is rho g z. So here rho oil into g into z. So then and this will be z will be z2. So which is 900 into 9.81 and my z2 will be 1. So which is 8829 Newton per meter square. And the second one what is asked in the problem is at bottom of tank. So which is at CD. So if you are considering this, the pressure will be due to oil as well as due to water. So both the things it will be acting on it. So I have to add on those things. So pressure intensity will be equal to rho oil G into Z2 plus rho into G into Z1. So density rho 1 will be 1000. So this I know it. So 8829 plus density of water will be 1000 and specific gravity is acceleration due to gravity is 9.81 and this is 2. So the pressure intensity will be 28449 Newton per meter square. So this is my answer. So this one answer and this is one answer. Thank you. Happy learning.